Imagine a silent traveler born in the fires of a distant star hurtling through the void at 130,000 miles per hour. It doesn't belong to our solar system. It doesn't play by our rules. On July 1st, 2025, astronomers in Chile caught a glimpse of something extraordinary. A faint speck blazing through the darkness, defying everything we thought we knew about the universe. They called it 3I/Atlas, the third confirmed interstellar object to visit our cosmic neighborhood. But this is no ordinary comet. Its chemistry is a riddle, its path is a statistical anomaly, and its very existence challenges the boundaries of science. Is it a natural wonder forged in the galaxy's most violent crucibles? Or could it be something more? A message from beyond the stars? Buckle up, because this story is about to take you on a journey that will leave you questioning our place in the cosmos. What's racing toward us, and what does it mean? Let's dive in. The discovery of 3I/Atlas didn't come with fanfare. It began as a flicker on a telescope screen, captured by the Atlas survey team in Chile. On June 14th, 2025, they spotted it, a fast-moving dot against the starry backdrop, too swift to be bound by our sun's gravity. By July 1st, the numbers confirmed it. This was no local comet looping back on a predictable orbit. Its trajectory was hyperbolic, with an eccentricity of 6.141, meaning it was a one-time visitor born far beyond our solar system, possibly near the galactic center. Moving at 58 kilometers per second, 130,000 miles per hour, it was already inside Jupiter's orbit, slingshotting around the sun before vanishing back into the interstellar abyss. This wasn't just a rock tumbling through space. It was a messenger from another star, carrying secrets in its composition. The scale of it is staggering. An object that's traveled for millions, perhaps billions of years, crossing the vast emptiness between stars to pass through our system. Its speed and unbound orbit place it in a rare class, joining only two other confirmed interstellar objects in history. The question isn't just where it came from, it's what it's made of and why it's here. If this kind of cosmic mystery excites you, stick around, because the deeper we look, the stranger it gets. What do you think this object could be? Drop your thoughts in the comments below, and let's unravel this together. As 3I/Atlas barreled closer to the sun, astronomers turned their most powerful tools on it. The Very Large Telescope VLT in Chile picked up something astonishing. Spectral lines screaming with nickel, a heavy metal forged in the hearts of dying stars. By late August 2025, the VLT measured 4.6 grams of nickel vapor streaming off the object's coma every second. But here's the kicker: there was no iron. None. In every comet, meteorite, or asteroid we've ever studied, nickel and iron are cosmic twins, forged together in stellar furnaces and locked in the same minerals. A typical solar system comet has a nickel to iron ratio of about 1 to 15, but 3I/Atlas? Iron is simply absent, making the ratio effectively infinite. This isn't just unusual, it's unprecedented. Harvard astrophysicist Avi Loeb, a name synonymous with bold ideas, was the first to flag this anomaly. Nickel without iron is like a fingerprint that doesn't match anything we know. He said in a recent statement, on Earth, separating nickel from iron requires industrial processes. In space, it's unheard of. Could a natural process in the depths of the galaxy produce pure nickel vapor without a trace of iron? Or is this a clue that 3I/Atlas isn't just a rock, but something engineered, designed to stand out? The mystery deepens, and the stakes couldn't be higher. What's your take? Is this nature's quirk or something more deliberate? Share your thoughts below as we dig into the next layer of this cosmic enigma. The James Webb Space Telescope, JWST, humanity's most advanced eye on the universe, added fuel to the fire. Its infrared spectroscopy revealed a chemical makeup that shattered expectations. 3I/Atlas is pumping out carbon dioxide at a staggering rate, 129 kilograms per second, compared to just 6.6 kilograms of water vapor. That's a carbon dioxide to water ratio of 8 to 1, the highest ever recorded for any comet, local or interstellar. For context, typical solar system comets have about 4% carbon dioxide in their volatile mix. Here, it's the dominant ingredient, dwarfing everything else. Carbon monoxide and carbonyl sulfide are present too, but nothing rivals the carbon dioxide spike. This isn't a minor deviation, it's a chemical scream. Comets are usually icy relics, spewing water vapor as they heat up near the sun, but 3I/Atlas is rewriting the rulebook. Some researchers suggest its surface might be a shell, baked by cosmic rays during a billion-year journey through interstellar space, locking in volatiles until it neared our star. Others wonder if this points to a formation process unlike anything in our solar system. Could this object have formed in a distant star system with wildly different chemistry? Or does its composition hint at something artificial, a structure built to carry specific compounds? The data is real, the questions are urgent, and the answers are elusive. What do you think this carbon dioxide dominance means? Let us know in the comments, because the next piece of the puzzle takes us even further into the unknown. This isn't the first time an interstellar visitor has shaken science. In 2017, Oumuamua burst onto the scene, a cigar-shaped enigma that defied categorization. Moving at 26 kilometers per second, it entered our solar system from above the ecliptic, accelerated slightly as it passed the sun, and left without a trace of a tail or coma. Unlike any comet we'd seen, its light curve suggested a bizarre shape, perhaps 10 times longer than wide, spinning every 8 hours. Some models proposed a pancake-like structure, others a thin solar sail. No natural explanation fully fit. Avi Loeb stirred the pot, suggesting Oumuamua's acceleration and shape could point to an artificial origin. The astronomical community pushed back, citing exotic ices or fractal dust, but no theory tied up all the loose ends. Oumuamua left us with more questions than answers, vanishing before we could study it further, but it set a precedent. Interstellar objects don't always follow the rules. Now, 3I/Atlas echoes that strangeness. Unusual chemistry, an improbable path, and a refusal to fit neatly into any known category. The pattern is eerie. Our solar system, once thought a quiet corner of the galaxy, is starting to feel like a cosmic crossroads, visited by objects that challenge our understanding. Are these anomalies just rare flukes, or are they clues to something bigger? Let's explore the historical threads that might connect these dots. What's your gut telling you? Share it below as we travel back in time to uncover ancient clues. Long before telescopes, humanity was captivated by materials from the sky. In ancient Egypt over 5,000 years ago, iron wasn't just a metal, it was a divine gift. At the Gerza Cemetery, archaeologists found iron beads with 30% nickel, a composition impossible for Earth's ores. These weren't smelted, they were meteoritic, forged in space, and shaped by human hands. Fast forward to the 14th century BCE, and King Tutankhamun's tomb held an iron dagger with 11% nickel and a crystalline structure, Widmanstätten patterns that only forms in the vacuum of space over millions of years. This iron of the sky, as Egyptians called it, was rarer than gold, reserved for pharaohs and gods. Across the ancient world, from Turkey to China, Bronze Age artisans worked with sky iron, always marked by high nickel and cobalt, distinct from terrestrial ores. These artifacts weren't just tools, they were symbols of cosmic power, proof that the heavens could touch Earth. Today, 3I/Atlas's nickel-heavy, iron-free composition feels like a modern echo of those ancient wonders. The same question that drove our ancestors, where do these strange metals come from, now haunts scientists. Is 3I/Atlas a natural fragment from a distant star, or could it carry intent like the crafted relics of old? The past and present are colliding, and the answers could redefine our future. What do you think connects these cosmic gifts? Drop your ideas below as we explore the violent forges that might explain this mystery. The universe is a brutal craftsman, forging elements and cataclysms we can barely comprehend. One possible birthplace for 3I/Atlas's strange metals is a kilonova, the collision of two neutron stars. In 2017, the gravitational wave event GW170817 lit up the sky, followed by a flash of light that revealed strontium, a heavy element born in the rapid neutron capture process, or R process. Kilonovae are cosmic foundries, slamming neutrons into iron group nuclei to create heavy elements like nickel in mere seconds. Some models suggest these events can produce nickel-rich, iron-poor clumps, especially in the tidal tails of debris flung into space. If 3I/Atlas formed from such a patch, its chemistry could be a natural artifact of this extreme process, cooled over eons as it drifted through the galaxy. Another contender is an asymmetric supernova, like the W49b remnant observed by the Chandra X-ray Observatory. Unlike tidy explosions, some supernovae erupt in lopsided jets, separating elements into distinct distinct regions. In W49b, nickel shoots outward in high-speed plumes, while iron stays locked in the core. X-ray maps show nickel-rich jets stretching hundreds of light years, carrying unique chemical fingerprints. If 3I/Atlas condensed from such a plume, its nickel-heavy, iron-free makeup could be a natural outcome of a star's chaotic death. Even its carbon dioxide spike might fit. Cosmic rays bombarding a fragment over billions of years could build volatile coatings that only release near a star. These natural explanations are spectacular but rare. Kilonovae and asymmetric supernovae are the universe's most extreme forges, capable of producing alloys that defy Earth's recipes. Yet the odds of such a fragment reaching our solar system, intact and alone, are slim. The chemistry fits, but the rarity of the event keeps the door open to other possibilities. What do you think? Could nature alone craft something this strange, or is there more to the story? Share your thoughts as we explore a path that's harder to dismiss. Avi Loeb doesn't just see odd chemistry in 3I/Atlas. He sees a trajectory that defies probability. The object's path threads the solar system with uncanny precision, passing unusually close to Venus, Mars, and Jupiter in a single flyby. Loeb's team calculated the odds of this alignment, a mere 0.005% or 1 in 20,000. It's like rolling a die and hitting the same number 10 times in a row. The math is stark. Each planet's position is a moving target, and for 3I/Atlas to skim their orbit so closely feels less like luck and more like intent. The trajectory has other quirks. 3I/Atlas moves in a retrograde orbit, opposite to the planets, and its path is nearly flat, tilted just 5 degrees from the solar system's plane. It reaches perihelion, its closest point to the sun, on the far side from Earth, making it hardest to observe when it's brightest. If something wanted to survey our system without being easily watched, this is the path it would take. Loeb isn't claiming it's a probe, but he's urging science to consider the possibility. With only 3 interstellar objects ever observed, the odds of one hitting this trajectory by chance are vanishingly small. Critics argue rare events happen in a vast universe, but Loeb counters, if the numbers don't add up, we need to ask why. Is this a cosmic fluke or a deliberate flyby? What's your take? Chance or choice? Let us know as we push deeper into the unknown. The idea of 3I/Atlas as a crafted object isn't just about its path or chemistry, it's about the possibility of intent. In 1977, NASA launched Voyager 1 and 2, each carrying a golden record, a time capsule etched with music, greetings, and diagrams meant for any civilization that might find it. Carl Sagan called it a message in a bottle, a physical archive designed to survive eons. Could 3I/Atlas be something similar? A cosmic courier carrying a message not in radio waves, but in its very atoms. Consider the nickel without iron, the carbon dioxide dominance, the improbable trajectory. Some researchers are now asking, what if the message is in the chemistry itself? On Earth, we encode information in DNA's chemical bases, or in the isotopic ratios of nuclear materials. A civilization advanced enough to manipulate matter at the atomic level could embed a signal in the isotopes of an alloy, a pattern too precise for nature to replicate. The nickel in 3I/Atlas is already anomalous. Could its isotopes hold a code? Labs are now re-examining every spectral line, hunting for isotopic ratios that deviate from natural processes. If they find a pattern that screams design, it would mean 3I/Atlas isn't just a rock, it's a deliberate artifact, a message written in metal, sent across the galaxy to be read. This isn't science fiction, it's science pushing its limits. We've sent messages in matter before, trusting future observers to decode them. If 3I/Atlas is a time capsule, every anomaly could be a clue to another world's history, technology, or intent. The alternative is just as thrilling. A natural object so extreme it forces us to rethink the universe's chemical factories. Either way, the search for answers is rewriting the rules. What do you think? Could this be a cosmic message, or is it nature's wildest creation? Share your thoughts below as we chase the final clues. The mystery of 3I/Atlas taps into something primal, our need to understand the unknown. From ancient Egyptians marveling at sky iron to modern astronomers parsing spectral lines, humanity has always looked to the heavens for answers. Each anomaly in 3I/Atlas, its nickel surplus, its carbon dioxide spike, its improbable path, is a challenge to our assumptions, a call to push beyond what we think is possible. This object isn't just a scientific puzzle, it's a mirror reflecting our curiosity, our fears, and our hope for connection. Whether it's a product of nature's wildest forges or a deliberate signal from another intelligence, 3i/Atlas reminds us that the universe is vast, unpredictable, and full of wonders waiting to be explored. What drives you to seek answers in the stars? Share your passion in the comments as we delve into the next chapter of this cosmic saga. If 3i/Atlas is indeed a messenger, it's speaking to us now in real time as it streaks through our solar system. Astronomers worldwide are racing to capture every photon, every spectral line, before it slips back into the void. The data pouring in from the VLT, JWST, and ground-based telescopes is building a picture that grows stranger by the day. But this isn't just a job for scientists, it's a moment for all of us to ponder what it means to encounter something truly alien. Could this be the first tangible clue that we're not alone, or a testament to the universe's untamed creativity? The answer lies in the collective effort to decode its secrets, and you're part of that journey. What question would you ask 3i/Atlas if you could? Drop it below and let's keep the conversation alive as we await the next breakthrough. The pursuit of 3i/Atlas's secrets is a testament to the relentless curiosity that drives science forward. Every observation, from the VLT's detection of nickel vapor to the JWST's measurement of an unprecedented carbon dioxide surge, is a step into uncharted territory. Scientists are now employing cutting-edge techniques like high-resolution spectroscopy and isotopic analysis to probe the object's composition at the atomic level. These methods, honed on Earth to trace the origins of meteorites or nuclear materials, are being pushed to their limits to unravel 3i/Atlas's story. The absence of iron, a staple in every known cosmic body, suggests a formation process that defies our models. Perhaps a kilonova's chaotic aftermath or an asymmetric supernova's skewed jets. Yet the possibility of an engineered origin lingers, fueled by the object's improbable trajectory and chemical anomalies. Researchers are cross-referencing data with simulations of neutron star mergers and supernova remnants, seeking patterns that might explain the nickel dominance or the carbon dioxide envelope. Meanwhile, teams are analyzing the object's light curve to infer its shape. Could it be elongated like Oumuamua or something entirely new? The global scientific community is united in this effort, with observatories from Chile to Hawaii coordinating to track 3i/Atlas before it fades from view. This is science at its most thrilling, a race against time to capture data that could rewrite textbooks. The questions are piling up, and the answers could shift our understanding of the cosmos, or our place within it. What scientific discovery excites you most about this mystery? Share your thoughts in the comments as we explore the next frontier. The arrival of 3i/Atlas forces us to confront a broader question. What else is out there waiting to be discovered? If this object is a natural relic, it points to a universe capable of producing materials and processes far beyond our current models. Colonovae and asymmetric supernovae are rare, but they hint at a galaxy teeming with exotic chemistry, where pockets of matter defy the predictable ratios we've studied in our solar system. If 3i/Atlas is artificial, the implications are even more profound. It suggests a cosmos where intelligent life has left markers, perhaps intentionally, for others to find. This isn't just about one object, it's about the frequency of interstellar visitors and what they reveal about the galaxy's history. Only 3 such objects have been confirmed, yet each, Oumuamua, 2i/Borisov, and now 3i/Atlas, has challenged our assumptions. Are we on the cusp of discovering that our solar system is a busy thoroughfare, visited by fragments or artifacts from countless star systems? The trajectory of 3i/Atlas, skimming past Venus, Mars, and Jupiter, raises the possibility that these objects are drawn to specific paths, perhaps influenced by forces or intentions we don't yet understand. Future missions, like the proposed interstellar probe, could help us intercept such visitors, but for now, 3i/Atlas is a fleeting opportunity. Its passage is a reminder that the universe is not a static backdrop, but a dynamic stage, where every new arrival could hold clues to our origins or our future. What do you think the next interstellar visitor will teach us? Drop your ideas below as we ponder the galaxy's next surprise. As 3i/Atlas races toward its exit from our solar system, it leaves behind a legacy that will shape astronomy for decades. The data collected, nickel without iron, a carbon dioxide to water ratio of 8:1, a trajectory with 0.005% odds, has already sparked debates that bridge science and philosophy. Is this a natural outlier, a product of cosmic forges we're only beginning to understand, or a deliberate signal from a civilization that mastered matter itself? The questions it it raises echo humanity's oldest inquiries. Are we alone? What is our place in the cosmos? The answers may not come in our lifetime, but 3I/Atlas has ignited a new era of exploration. Telescopes are being upgraded, algorithms are being refined, and international collaborations are pooling resources to scan the skies for the next visitor. The object's passage has also inspired a wave of public interest, with citizen scientists and enthusiasts joining the conversation, analyzing open source data, and proposing theories. This is a moment where science becomes a shared human endeavor, uniting us in wonder and curiosity. Whether 3I/Atlas is a natural marvel or a cosmic artifact, it has reminded us that the universe is full of surprises and we're only scratching the surface. As we await the next data release, expected from the JWST in late 2025, the world is watching, eager for clues that could tip the balance. What legacy do you think 3I/Atlas will leave for future generations? Share your vision in the comments, like this video to join the cosmic journey, and subscribe to stay in the loop as we chase the truth among the stars. The data from 3I/Atlas is undeniable. As of September 3rd, 2025, no laboratory has replicated its exact alloy composition. The VLT and JWST confirm a nickel-heavy, iron-free makeup, a carbon dioxide to water ratio of 8:1, and a trajectory with odds of 0.005%. These aren't just numbers, they're a challenge to everything we know. If 3I/Atlas is a natural object, it points to cosmic processes, kilonovae, asymmetric supernovae, that push the boundaries of stellar chemistry. If it's engineered, it suggests we're not alone, and someone or something left a calling card in our solar system. This isn't just about one object, it's about our place in the universe. For centuries, we've looked to the stars, wondering if we're alone. 3I/Atlas, like Oumuamua before it, suggests the galaxy is more active than we imagine, a crossroads where strange visitors carry secrets from distant stars. Every new observation, every unexplained reading is a piece of a puzzle that could redefine humanity's story. The next data release, expected soon from the JWST, could tip the balance toward a natural wonder or a discovery that changes everything. The search continues and you're part of it. What do you think 3I/Atlas is? A freak of nature or a cosmic message? Drop your thoughts in the comments, like this video to join the conversation, and subscribe to stay updated as new data drops. The universe is speaking, let's figure out what it's saying.